Welcome to qnawire.
So now we'll work on problem 76 from chapter 20. In this problem, we are told that mercuric oxide dry cell batteries are often used where a flat discharge voltage and long life are required, such as in watches and cameras. The two half-cell reactions that occur in this battery are shown below. And the first thing they want us to do is write the overall cell reaction. So first, we can go ahead and put the two half reactions down here. So we're showed reduction and oxidation reactions in that form, so we don't need to flip either of them. So first we have mercury oxide plus water producing two electrons, producing mercury and two hydroxide anions. And our second reaction is zinc plus 2 hydroxide, producing zinc oxide and water and 2 electrons. So we go ahead and add these reactions up. The hydroxides will cancel, the waters will cancel, and we get mercury. The electrons will also cancel, so we get mercury oxide plus zinc, producing zinc oxide plus mercury. So that's the overall reaction, which is relatively simple. In part B, they ask us to, or they tell us that the value of standard reduction potential for the cathode reaction is 0.098, and the overall cell potential is 1.35. And so we assume that both half cells are operating under standard conditions. They ask us for the standard reduction potential for the anode reaction. So we have E standard is equal to 1.35 volts, which is equal to the reduction, which is 0.098, minus the reduction at the anode. So we solved for this reduction at the anode, the potential. So we subtract 0.098 from both sides, and we get a value of negative 1.25 volts for this anode reduction potential. Then they ask us, why is the potential of the anode reaction different than would be expected if the reaction occurred in an acidic medium? So the reason why this would be different than what we would expect for an acidic medium is because if we look directly at the silver overall reaction, we don't immediately see it. But if we look at each of the half reactions, we can see that OH is a product or reactant for both of them. So this reaction, this overall reaction, requires base. To generate zinc oxide. Specifically for that half reaction because it's a reactant versus a product. So if in base we would have much less OH, much less base, so this reaction would not proceed as easily.